Hello everybody, welcome, good afternoon, welcome to another Fronius webinar. Today we are talking about surge protection and how to maximize your safety. I'm very pleased to welcome you today here to another Fronius webinar about a very special, a very interesting topic, I guess. And I quickly want to introduce myself. So my name is Curl Sandro. You see me here on the left picture. I am from Team Trainings and Education at Fronius International at the headquarters in Austria. And my colleague on the right side, Schirlinger Christoph, he is in Team Trainings too. He will support me today throughout the webinar and answer your questions. So if you have got any questions related SPD, surge protection, or Fronius in general, so please directly address them to Christoph in the chat. He will give you immediate reply to your concerns and questions. And afterwards, he will join live the webinar and point out the most interesting and most frequent questions which came up during the webinar. Good. What's on the agenda for today? So first of all, I will give you a general overview of surge protection. So why is surge protection so important with regards to safety? How does a SPD work? We will also define what different types of SPD are available on the market. That's something regarding classification and types, and also some myths I will sort out today within this webinar. The second big part is different country requirements. So yes, also the participants of the webinar, so that means you, we are globally spread. There are really different requirements depending on the country. And I will give you one example out of Germany, and which is more or less similar to the all over European situation. And third part are the Fronius solutions. That means I will give you an insight what is Fronius providing in topics of SPD, and I will also show you our retrofit kit. That means our new device for our inverters. But actually, before I start, I have prepared a quick poll for you. So I want to ask you following question. Do you already know Fronius SPD solutions? That means surge protective devices. First possibility is yes, I know the SPD solution for the big SnapInverter. Second possibility, yes, I also know the retrofit kit for small SnapInverters. Third possibility, I know all of them. I'm more or less a Fronius professional. And fourth possibility, I don't know so far. So please give me your feedback, very valuable also for upcoming webinars regarding new topics, that I have a quick overview over your knowledge. So I see many of you voting already. I will still wait a few seconds until I will close the poll and present you the results, of course. So thanks a lot. Nearly everyone voted so far. I will now close and show you the results. And following results are given. Approximately 1/4 already knows the solution for the big SnapInverter. I would say the greatest part, around 60%, do not have any knowledge so far. And the other 20% is more or less they know pretty well about the Fronius solution. So thank you very much for that. I think this webinar definitely includes valuable information for all of you. And let's directly jump into the presentation. So first of all, I want to give you a general overview of surge protection. So why is surge protection so important? For this case, I have pointed out one recent study of the Aviva insurance company. This Aviva insurance company is one of the big 5 players in the insurance company sections worldwide, and they have done a also investigation. So they looked at the causes of damages to power electronics in general. And what is the result? You see here, the 61% are caused by surges. So that means more than a half, and a very great extent of the overall number is caused by surges. And therefore, this is the most frequent cause of damage. Why is this so? Of course, power electronics has got an increased sensitivity. That means there is also a very many applications, and therefore also a very high probability that something could occur with power electronics. This is also very dangerous in some cases because a surge can have serious consequences. Just think of fire, heat damages which are caused by surges, and therefore we can say surge protection is a very important factor and is definitely something you have to consider when planning your PV system and when doing system design. Coming to the PV system, another study I want to present to you that's a cause of damages to PV systems in general. So the previous one was linked to power electronics, and this one is specific on PV systems. And also again on this study you see around 18% are caused, or the damages are caused by surges, and 21% by fire. That means fire is also somehow often linked to surges, and therefore it's also a very frequent cause of damage to PV systems. What happens in case of surges? So these are short-term transient surges. That means little nanoseconds in form of lightning discharge, electrostatic discharge, and switching operations where a surge can occur. That means such surges can lead severe damages to hardware and software, also in the PV system, on the inverter. And in worst case, it can lead to a failure of the overall system. That means you have got downtime of your PV system, which we of course want to avoid to the greatest extent, because downtime means service, means an error, means of course costs and inconveniences for you and your PV system, which we want to avoid. But of course, there is an imminent danger from lightning. I have also another map for you here. You see the global map of the world you see here. Many of us are spread over the world. We are sitting here in Austria today. But this chart, which I want to show you, is the so-called NG chart, and which indicates the lightning density all over the world. That means, to quickly summarize, the darker it gets on the map, the higher the probability that a lightning strike occurs in your area. And you see in specific areas of the world, I would say in Africa, in the southern central part of Africa, also in Latin America, in parts of Northern America, and also in the Asian part, there is really high lightning density and a high density of lightning strokes per square kilometer per year. This NG charts, of course, indicates this lightning density. This is validated data. So just one example out of Austria, where we are sitting today, which is in the heart of Europe. We have approximately all over Austria 100,000 to 280,000 cloud earth strikes per year, but we are not that dark on the map. That means we do not have that big lightning density like, for example, other parts of the world. But of course, these are very high numbers. What I would now point out is, of course, each strike, each lightning strike is a potential risk. That means for your PV system or for your electronic equipment at all. And therefore, surge protection is again a very important factor. What types of lightning strikes endanger now PV systems? So we differentiate between different lightning strikes types. It means on the one hand, there are direct strikes. That means the PV system is directly affected, directly struck by a direct lightning strike. There are also indirect strikes. That means this can hit your PV system by electrical installation or the grid, for example. And then we have two distances which often come up in when it comes to PV lightning strikes. That means lightning strikes up to 500 meters of distance. That means that also leads to high magnetic fields of the lightning strike, and which can also result in surges and overvoltages. And then we have lightning strikes above 500 meter distance, but therefore, fortunately, I can say this above 500 meters, there is no imminent danger for your PV system. So we are mainly focusing on these three types of strikes. What happens now in case of a lightning strikes? So I already talked about these transient surges. So lightning strikes are not foreseeable. They do not have any periodical voltages, currents or loads. So they just happen, of course. And a typical lightning strikes is subdivided by different charges and currents. So you see here one type of lightning strike. Of course, it's divided in such leader charges. It means they catch charges and build up the main lightning discharge, which happens afterwards, which all its ramifications you can see when looking at the strike. And then it's divided within impulse currents and long time currents. And especially these long time currents, that means high currents, high discharging over a very long period compared to impulse currents. These ones are very, very dangerous and are the main cause for serious damages or fires on your PV system. Also, when it comes to indirect strikes, we also talk about AC-sided surges. That means you can also have damage of the varistors on the AC side of the inverter. It means this can happen due to indirect lightning. What is the intention of a varistor? Of course, it should watch the voltage between phase and neutral, and if it's exceeded or if there is a bad or missing connection of the neutral conductor, such surges on the AC side can happen. Of course, different protection systems exist, of course, which arrest these surges, but below the line we can say a defect functionality of resistors cannot be excluded. So just think of these surges. This is force majeure. This is really a higher force which can happen, of course, anytime. But how to optimally protect a PV system now? So what can we do to ensure this protection to the max? And there are 4 basic steps we have to follow, of course. First of all is a good grounding and potential equalization. It means this one forms the base of each surge protection systems, and therefore it's very important to keep the grounding resistance as low as possible, and it means below 10 ohms. Then, of course, installation is also crucial when it comes to safety aspects in general. And when it comes to PV systems and surge protection, this cable routing is very, very important. It means you have to keep the conductor loops as small as possible and separate protected and unprotected cabling. And therefore, installation is also a main part. And then we come to external lightning protection. Maybe you have installed already an external lightning protection, or you know PV systems which include external lightning protection. Of course, it makes totally sense to install such external lightning protection and also integrate the PV system in this overall concept. Therefore, also there are specific requirements, but you have to take into consideration that this is the main profession of experts. So there are own lightning protection experts which have got massive knowledge on that if you want to integrate such a PV system in an external lightning protection system. What we today are focusing on to the greatest part is this internal lightning protection. These are so-called SPD devices, surge protective devices for potential equalization. There is quite a big range of different typologies. That means there are different types of SPDs in different classes. And the good thing about Fronius and SPD is we have got integrated in devices, means in some you can order it for the big SnapInverters X factory that they're integrated, and there is also a possibility to retrofit it. That means you do not have any external box or external device. Everything is integrated in the inverter and you have maximized safety with Fronius. What to consider when doing such a overvoltage protection or surge protective device? That means, of course, it's an internal lightning protection for potential equalization I just mentioned before. What we also want to ensure is the economy and the higher yields. Of course, we want to avoid downtimes, we want to avoid service times, maybe we also want to avoid damage to the greatest extent, that there are no reinvestments necessary, that we can ensure safety for our customers with our integrated SPD solutions. And also when it comes to insurances, that means if your customer want to insure, have an insurance on their PV system, often it is asked by them. That means it's regulated that they require an integrated SPD for the PV system, or if this isn't the case, higher premium rates are therefore have to be charged, and this has also been taken into consideration. And of course, inverter protection to the greatest extent, that means it's of course a big factor of safety which we can easily implement within our inverter in case of refitting or inbuilt for some devices with Fronius. Briefly to the typology of SPDs. So there are different types. There is type 1+2, that's a combination arrestor. There is the type 2 only, which is the surge arrestor for middle protection, and the type 3, which is the fine protection. It means this is one is the in-house for effective elimination of small surges, and is often done in combination with this one, with the previous ones, with the type 1+2 or the type 2. How are they characterized? That means also always the residual voltage. That means type 1 is, of course, the coarse protection. Type 2 is the middle protection. And it's always depending on the type of SPD, what residual voltage is remaining. And this is, I think, very important because it's often misleading information on data sheets, and also sometimes customers or installers are not interpreting it correctly. That means please do not just mind the difference between overvoltage category and overvoltage protection. These are two different things. I've listed here up the overvoltage category. That means these are 4 categories, 1, 2, 3, and 4. That means there is a rated surge voltage and one example. I've also listed it up. But that has effectively nothing to do with the SPD device, because that's something we have to do as an inverter manufacturer. That's a thing we have to deliver to sell our inverters. So one example is here we've got the overvoltage category of Fronius. The SnapInverters has got this category 2 on the DC side and 3 on the AC side. So this is always depending on the components. That means on the cable cross sections, on the isolation, on the air gaps, on the overall design of the R&D, and then the overvoltage category is defined. And therefore, please mind the difference between overvoltage category and overvoltage protection, means SPD, that these are two different things. And also a myth which is sometimes spread by some people: two PV systems attract lightning. Some end customers believe that sometimes. There is a clear answer: no, of course not. PV systems on the roof do not increase the risk of a lightning strikes. That means there are a lot of scientific proofs that a lightning strike is always looking for the highest point of the building. And in normal cases, a PV system is not making a building higher. It means it's on the roof, it's roof integrated, and therefore the same height. And therefore, this is not the case that a PV system attracts the lightning. Nevertheless, it makes sense to consider lightning protection concepts and SPDs. That's definitely also a recommendation we give from Fronius, that you take this into consideration when doing PV system design. Okay, so much to say to the SPD options and what is SPD in general. And now we really look into a country-specific example. That means how it is done in the different countries. So generally we have to say there are many international and national standards. So we cannot give you a general answer on your country, on your regulation, because often it's also within the country there are different regulations and laws. Principally, we have to differentiate between a standard and a law. That means these are two different things, and often laws refer to standards, but they're also sometimes linked. But a standard is not a law. That is also very important. What is therefore important when it comes to damage, or I would say overvoltage in general? That means the law often refers to three things. That's on the one hand, the state of science, the state of technology, and the rule of technology. It means if there happens a damage on a PV system, there are always technicians included in, okay, what was the reason for the damage? How could this be prevented, and so on. And therefore, the law often refers to these three terms. And when it comes to SPD, that means surge protective devices, we are no longer in a state of science. We are also no longer in a state of technology. We are in the rule of technology. That means SPD is widely spread, that's standardized, that works, that is not anymore in a scientific state anymore. And therefore, it can happen that the law or the lawyer, for example, refers to the rule of technology. And if you do not have an inbuilt SPD or a general SPD for your PV system, you can have there is a threat that you have any problems coming up due to this lack of safety. One country-specific example I want to give you now is in Germany. So there is a very strict law, which is mainly also all over Europe the same. and I will give you the key facts on this. What is in Germany? So there is a DC SPD required for every PV installation. That means there are different standards and norms which define, okay, which SPD when has to be the SPD installed and which distances. And one common rule, which you also find in other parts of Europe, often is this 10 meters of rule. That means there is often referred that you have to set an SPD directly after the entry of the house. That means here, if the distance from the inverter to the cable, DC cable entry of the house is below 10 meters. When it is above 10 meters, that means that this SPD is 15 meters, for example, away from the inverter. You have to set another SPD directly in front or to the closest to the inverter to ensure the safety and the correct surge protection. So this one is the 10 meters rule, which is relevant, I would say, also in Germany, Austria, and many other European countries. So generally, this VDE standard is regulating when you have to do SPD and what type is therefore required. Maybe also some insights in this, since when this standard is so important. So already required was a SPD installation for public buildings. That means if you have a PV system installed where human life is somehow affected, or there are public institutions or also commercial applications. And new, that means since 2016, there is an overall law that means that includes also SPD requirements for gathering of people and also private individuals. That means you also have to install a PV system for residential applications, and below the line, every PV system has to be equipped with an SPD. Now, maybe the question raises which SPD I have to use for what application. Therefore, you also have to differentiate between AC side and DC side. And it's also definitely depending on different frameworks, more or less. If you have got this external lightning protection, or if you do not have this external lightning protection, therefore it's very important. But that was the AC side. I do not want to go into detail of the AC side. Much more important is for us the DC side, and where also the PV generator and the PV inverter comes into the game. So therefore, in the standard, there is clearly defined the scenario. That means if you have if you do not have an external lightning protection, if you do have, and if you do have, there are also two different cases. If you have this separation distance, it means the distance from the PV system to the external lightning protection must be around 1.5 meter and 1 meter. That's also depending on the type of external lightning protection. But if this separation distance is complied, you have different SPD types required. Or if this distance, this 1 meter in general, we can say is not complied, you also have different requirements regarding SPD. And therefore, you see the SPD type 1 is therefore required when the separation distance is not complied, and if you have an external lightning protection. But I would say the most common application is that at the residential scale, you do not have an external lightning protection, and therefore on site 1 and site 2, the SPD type 2 is required. You see here the positions once again. You will receive the slides, of course, afterwards. You can go through it once again and look up the exact standard and look what is required. But what can be derived from the country-specific analysis in general? So in general, we can say for every PV system in Germany, SPD is required at the house connection as well as on AC and DC side. That means on the DC side, the SPD should be mounted as close as possible to the inverter. That means you also have to take into consideration this 10 meters rule, more or less. If it excesses this 10 meters rule, an additional SPD has to consider it. It means please take care of these basic rules, of course. Okay, so much to our country-specific view I gave you now about Germany. Now I want to directly hit into the Fronius solutions and the retrofitting, of course. So what are we offering in terms of SPD? We have got the solutions. We have got solutions for all of our inverters. That means, but before we look at this, we have to differentiate between the inverters because there are different solutions. Whether it's a small snap inverter, that means up to 8.2 kilowatts of AC output power, or it's a big snap inverter, that means bigger housing from 10 kilowatts on. So there are different SPD options and versions, but we have the overall solution for every inverter, of course. And how to successfully retrofit the SPD? So when it comes to the small snap inverter, I want to kindly refer you to a video on our YouTube channel. So that's a really, really good video on our YouTube channel where you find the proper installation tutorial. And you see its duration is very, very not long. That means in 3 minutes you see the overall installation of a retrofitting a surge protection. Of course, when you do not have the possibility to watch the video, there is also, when you buy this retrofit solution, there is a manual included with some pictures. Maybe here the key facts. So you see here we have the SPD inbuilt in our inverter. That means here you have got the wall bracket and the connection unit. And on the left side, you see this DC SPD print. It gets integrated in our inverter and then connected to DC plus and DC minus. There is an additional contact you see here, which comes on the front side here. That means that's the signaling contact from the SPD to our inverter display on the SnapInverter series. And this gives you, of course, the feedback when there is a triggering of the DC SPD. So what is the Fronius solution up to 8 kilowatts? That means for the small snap inverters. Once again, you see it here in a real life application. So it's an inbuilt retrofit kit. That means on the left side, it's type 2 plus 1. It's a M version. This means for 2 MPP trackers, you have the full protection. We do not have installation X factory. That means for the small snap inverters, you have to order it via the wholesaler. And we had to do some hardware adaptations for that. You see here, it's mounted on the wall bracket on the connection unit. So retrofitting is available from all the inverters which were produced starting from calendar week 40 of 2019, so quite a while already, and therefore it's possible to do this retrofitting of the SPD kit. Its name is here, so that's the name how you can order it via your wholesaler, and that's the kit which you get delivered from Fronius and from your wholesaler. We had to do some adjustments, that means hardware adaptations. That means since the calendar week of 40 to 19, these were adapted in our snap inverters. You can see here on the shell, we have to do some opening to route the signaling cable, and also on the wall bracket there were 3 fixation points you can see here That means that you can install the print within the connection unit. And that's the retrofit solution for the small SnapInverter series of up to 8.2 kilowatts. And more, maybe also one prospect for the upcoming months. Our Gen 24 Plus series is of course about to come, our new hybrid inverter series. And also for the Gen 24 Plus, there will be such retrofit solution available. You can see here it looks a little bit different to the SnapInverter solution, a little bit bigger, but it's also again the same principle. It's a retrofit kit. We do not have an installation X factory. You can order it via our wholesalers and do the retrofitting on your own if it's needed. For the SPT solution, we work together with a company called CTEL. That's, I think, a very well-known company when it comes to surge protection. These are the key facts of our SPT, 600 volts DC of nominal voltage and 1200 volts of maximum operating voltage. You see here on the front side of the SPD, there's a disconnection indicator, this mechanical indicator, which turns red when the DC SPD is not working anymore properly. And we are compliant to all these standards in the markets, the ISC standard, UL standards, European standards, and also the VDE. So we are 100% standards compliant to your markets. So much to the small snap inverters, and when it comes to the big snap inverters, that means from 10 kilowatts on, and also for our commercial ones at the moment, the Fronius Echo and the Big Simo. We have got 4 different technical designs, so therefore we offer the possibility to make installation X factory, so that's possible with the big snap inverters. But you can also have it as a retrofit version. You see here it's mounted on a DIN rail at the corner of the inverter, and therefore we offer different types, type 1 plus 2 on a S and M, that means single MPP tracker and 2 MPP tracker version, and type 2 only, also again in the single and multi MPP tracker version. Again, like I told, installation X factory is possible, but also retrofitting on this course, of course, you can do it afterwards on yourself. Again, the technical details, we rely again on CTEL, a very reliable partner for us, and technical data here listed if you are interested, again, compliant to all standards. And the hardware installation is the one part, and the other part you have to do when successfully installing a retrofit SPT is to do few settings on the inverter menu on the display. So that means you just have to open on the inverter display the access code and enter menu. Therefore, you have to enter this code just quickly and 2 following steps. These steps are, of course, all listed within our YouTube video, and you get them all with our manual. What I just want to tell you, please be sure to not only do the hardware installation, to also activate the SPT on the software base, that you get the feedback and the trigger response. You have to activate it with a few steps. And one tech tip I want to give you here on this point of view, if you often work with Fronius and want to remember the codes very quickly, you can have this basic menu. So this 22742, this number combination is the basic menu. And if you open your number template of your mobile and enter basic, you receive this number, and therefore are very, very fast and easy to have the access to the Fronius inverter. So a quick tech tip if you're working more often with Fronius. And of course, I want to point out what happens in case of surge. That means, yes, we do not hope that this case affects us or our customers, but of course it can occur, and it will of course occur. Yes, lightning strikes and surges count as force majeure. That means our Fronius warranty cannot cover the damage, because there is also a residual risk in spite of these protection measurements. So we cannot guarantee you 100% of safety. You can maximize your safety with this surge protective device, but we cannot guarantee you 100% of safety, because it's force majeure. That means that it's something we cannot influence, of course, lightning strikes and surges. Therefore, it can happen anytime. What happens at the Fronius inverter if it's directly affected by a strike? That means normally, in normal case, there isn't a sending to our inverter display, and there isn't an error state code. That means the functionality of the inverter should be guaranteed and should be generally continuously be given. Of course, there cannot be excluded any damage to the hardware or the software due to this force majeure. And there only happens an error state code, that means on the inverter front side, if there is a failure of the SPD. But generally we have to say SPDs and varistors are designed to withstand these surges multiple times. So therefore, this error state code maybe do not comes up when there is at first time a lightning strike. And to summarize the key advantages with the Fronius SPD solutions, of course, we are here to maximize the safety with our solutions. You have got substantial advantages, of course, with Fronius. Why? Of course, we want to keep the installation costs and the installation time as low as possible. We guarantee you full standard compliance to your local standards with our solutions, and everything from a single source. So that also brings you benefits if you rely on our solution. So our solution is inbuilt. That's a Fronius approved solution. We provide you full support when installing, when there happens an error. So therefore, please be sure that you rely on Fronius and therefore have a very reliable partner on your side. Okay, so that was it basically. More information you can find on our homepage, of course, to all this installation and commissioning guides, also when it comes to SPD. Maybe you also come by once to visit our trainings. We offer a wide range of different product trainings. It means at our headquarters in Wales or somewhere near you, where we also will show you how to build in an SPD, and we will go more into detail about our options. And we are also very active on our YouTube channel. That means there are a lot of videos, how to install videos, webinar recordings, and so on. So before we close, I quickly want to ask my colleague Christoph. Christoph, are you still online?
Yes, hello. Also there.
Yes, thanks.
Yeah.
So Christoph, did we receive any questions from the audience or?
Yeah, so actually we got a few of them. There's still some questions coming in, and there are some very specific questions I don't want to answer now live, but I want to repeat some topics. Sandra already mentioned them, but there are still some questions arising to this topic, and it's about if there are some SPDs available for Echo and SIMO inverters, so the bigger ones, and if they are coming pre-installed. So yes, there is the possibility to install SPDs inside Echo and SIMO, and it's also possible to have it pre-installed, so ex-factory. but it's not standard. So if you want it, you have to pre-order it. And you can also do a retrofit, of course. So when you already have them installed somewhere and you now want to add the SPDs, you can order the retrofit kit, go on site, install it there, and activate it like Sandro showed us in the video. As he also mentioned, we have a very detailed, quick guide, also in form of a YouTube video, if you want to do the retrofit there. Yeah, and I see now another questions about, do we need 2 SPDs for DC and AC separately? So if the norm says you have to do an SPD also on the AC side, you have to do a separate one. Of course, it's not the same input, but that's actually depending on the regulations of your country, of your grid operator. Yeah, so now I can see loads of questions coming in. I would suggest we answer them now in the chat, and I'm gonna mute myself again, and I will answer you via chat then.
Okay, so thanks for that, Christoph. So like Christoph told already, we will stay a few minutes online after the webinar now to answer your questions. So if you have any questions left, so please feel free to ask them to us now. We will give you the answers. So far from my side, once again, very thanks a lot for your participants. I hope you could learn a little bit about SPDs. It got a little more clear to you. Please check out the webinars, of course. A lot of webinars are coming up in the future due to current crisis. Of course, we are also all stuck in home office and you cannot attend a live training, and therefore we are focusing on virtual trainings. So thanks a lot. Just check the webinar dates, and I hope we hear or see us hopefully soon. And goodbye. Have a nice day. Bye.